Welcome to the California High School Exit Exam in Mathematics section of www.happynumbers.org. Today's lesson is dealing with the concept called one of the strands called number sense, and we're going to deal with the concept called scientific notation, which is a special way of writing numbers, and I'll explain that to you. Let's take a look here. So scientific notation is a very quick way to express very large or very small numbers. Here's an example. The sun is approximately 14,963,000,000 kilometers from the Earth. Now that's a big number, 14,963,000,000. It's a very big number. And if we had to add or subtract or multiply or divide numbers like this, we'd go crazy. So there is a thing called scientific notation where this number, this 14,963,000,000, is put in this format. And then it becomes very, very easy to, or much easier to work with. So one of the things that we're going to learn is how to change big numbers like this, pardon me, into scientific notation. Pardon me. Now take a look at this number, this scientific notation version of this big number. It has three distinct parts to it. It has a decimal right here, 1.4963. And then it has multiplied by 10 to a certain power. In this case, it's 10 to the 10th power. So all numbers that are turned into scientific notation will have a decimal of some kind, will be multiplied by 10, and will have a power or an exponent. That's what a decimal in scientific notation will have a decimal point, be multiplied by 10, and have an exponent. Now on the California High School Exit Exam, you'll be asked to turn a number into scientific notation, to take a large number like this and to turn it into a number like this, which is in scientific notation. Or you'll be asked to take a number that is in scientific notation, a number like this, and turn it back into its original number. And so we're going to take a look at those skills. Let's take a look here. Okay, now this is turning a number into scientific notation. When the first thing you do, and here's the skill set when you're given a big number like this, the first thing you do, if you were reading this number from left to right, you ask yourself, what is the first non-zero number that you see? Well, the first non-zero number, if we're reading from left to right, is 2. So the first non-zero number is 2. To put this number into scientific notation, we first put a decimal point after the first non-zero number, or the number 2. So we have the number 2, and then we put a decimal point after it. And then we list the remaining non-zero numbers. In this case, it's just the 8. So we locate the first non-zero number on the left. We put a decimal point after that. The first non-zero number was 2. We put a decimal point after it. And then we list all other non-zero numbers. In this case, the only other non-zero number is the number 8. The second step is to figure out what the exponent will be. So we know that a number in scientific notation has 3 parts. It has a decimal, so here's the decimal. Then it's going to be multiplied by 10, okay? And now we have to figure out what the exponent will be. To do this, we count how many numbers, including zeros, come after the decimal point. In the above, 9 numbers come after the decimal point. So we put the decimal point here, and we wrote the 8. Now we're going to count how many numbers after the decimal point come after the decimal point. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 numbers come after the decimal point. So we have taken this number right here, which is, by the way, 2,800,000,000, and we have written it in this format: 2.8 times 10 to the 9th power. Let's just review how we did that. We located the first non-zero number on the left, which was 2, and then we put a decimal point after it, and then we put any other non-zero numbers. Then we went back up and we counted from the decimal point how many numbers there were going to the right. It was 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 2.8 times 10 to the 9th power. So we have changed this number into scientific notation, which is this number. Let's take a look at another one. Here we have 350,000. 350,000. We're going to turn it into scientific notation. We're looking for the first non-zero number on the left. The first non-zero number is 3. And then we put a decimal point and we write any other non-zero numbers. In this case, it was 5. Then we have, and we know that a number in scientific notation has a decimal. Then it's times 10, and we have to figure out what is the exponent. What is the exponent going to go here? The way we do that is we count all of the numbers to the right of the decimal point. So we start with the 5. 1, 2, 3, 4, 5 numbers. So it would be times 10 to the 5th power. So if we take 350,000 and put it into scientific notation, we have 3.5 times 10 to the 5th power. Now, this is turning scientific notation into a number. Well, let's see how we would do this. If the problem asks you to turn a scientific notation into a number, then look at the exponent first. Here, our exponent is 12. So we simply move the decimal point 12 places to the right. Here's our decimal. We have 3 point, and now we're going to move this decimal point 12 places to the right. And there we have it. So here we have 3,070,000,000. That's the number, and here it is in scientific notation. So what we did when we looked at the scientific notation, let's try that. We looked at the scientific notation, we had the decimal point here, and then we looked at the exponent. The exponent was 12, so we knew that we had to count 12 places going to the right. Let's watch it again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And that we have converted this scientific notation into the number. Let's take a look at another one. So suppose we are given this problem, 2.8 times 10 to the negative 3. The exponent is negative here. Now, we look at the exponent and we see that it's negative. To solve this, we just take the decimal point and move it 3 places, not to the right, we move it to the left. Picture a number line. Here is 0. If the numbers are positive, we move to the right. But when the numbers are negative, we move to the left. Well, in scientific notation, if the exponent is negative, then we move the decimal point to the left, not to the right. And since it's -3, we're going to move it we're going to move it 3 places to the left, or to the negative. So we have 2.8, and let's convert it. Okay, So we had the decimal point here, 2.8 times 10 to the negative 3, and we moved it 3 places in a negative sense to the left. 1, 2, 3. So 2.8 times 10 to the negative 3 is 0.0028, or in decimal fractions, this would be 28 10,000ths. 28 10,000ths. So if the exponent is positive, we know we move to the right. If the exponent is negative, we know we move the decimal point to the left. Positive exponent, decimal point goes to the right. Negative exponent, decimal point goes to the left. And the way you can remember that is if you just think of a number line and where the positive numbers are on the right side and the negative numbers are on the left. Take a look at another one. Suppose we were given this problem. 1.63 times 10 to the negative 9th power. Negative 9th power. Well, again, we look at the exponent, we see that it's negative 9, and we know that if the exponent is negative, we're going to be moving to the left. Moving to the left. So all we do then is to move the decimal point 9 places to the left. And it would look like this. Okay, the decimal point was here, right here. We had 1.6, and we moved it 9 places. 1, 2, 3, 4, 5, 6, 7, 8, 9. So, fairly simple skill. If this were 1.36 times 10 to the positive 9, then we would have moved the decimal point 9 places to the right. But since it's negative, we move it 9 places to the left. Now, here is a very typical problem that I'm going to give you on the high school exit exam. When the number, and I think this may be 16,300,000,000,000 billion. I think that's what that number is. Let's see, thousands, millions, billions. No, I don't, maybe even higher than that. I don't even know how to read that number. But if we had to change it into scientific notation, we would locate the first non-zero number, which would be 1, and then we would put the decimal point, and then we would list any other non-zero numbers. So it would be 1.63 times x. And here they say the exponent is n, and they want you to figure out what n is. What number is supposed to be n? Well, we know we just count every number after the decimal point. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So n should be 16. And n is 16. So what we did is we located the decimal point after the first non-zero number, and then we counted all of the numbers, and there are 16 numbers after the decimal point, so the exponent would be 16. So n then would equal 16. Okay, fairly simple skill. Okay, now it's your turn. If you have me for class, then what I want you to do is to copy down these problems, put the DVD on pause, copy down these problems, solve them, and then bring them up to me, and we'll take a look at it and see if you've gotten the skill. If you don't have me in class and you're just viewing this on the internet or something like that, and you would like to send me your answers, you can send them to this email address. Send them to happylearning@happynumbers.org. And just email me your answers, and then I'll get back to you and give you some feedback. So again, if you're in class, put the DVD on pause, write down all the problems first, and then solve them, and then bring them up to me. And if you're just out there in cyberspace and you'd like some feedback, then just email them to me. Thank you very much, and we'll see you next time.